story begins on an April afternoon when I bring a load of red oak in from my kiln. It's been drying all winter after my client delivered the wood in the fall from their very own oak tree. The first thing I did was to stand up all the oak on edge so I could get a good look at what we have. This is a mock-up of the top for the wide cabinet. I'm using 5-inch wide, 1 1/4 inch thick oak planks for the frame. So it's going to be a really robust frame. Inside the frame will be a panel that can move some. This top is going to have an undercut at an angle presentation, maybe 45 degrees or so. And so I debated whether to do a mitered corner or a butt corner, and I decided to go with the butt corner using Domino tenons. And the reason I did was because with such wide stock, I was concerned that due to seasonal changes in humidity and corresponding wood movement, that a mitered corner would have a tendency to open up seasonally, and I didn't want that to happen. So if I do my dominoes so that the wood is pinned near the outside and cut my slots a little wide on the inside, then these side pieces can actually grow and shrink towards the center panel. I just have to leave enough clearance in the center panel for that small amount of movement, and I should maintain a very flush outside edge. So the next step I'm going to do is to cut dominoes in this, then we'll cut a groove around the inside before we glue this up such that the panel can fit into the groove. Then we'll cut the panel to size, make sure everything fits perfectly, put some finish on the inside parts that I can't get to later, and then we'll glue it up, and following that I'll cut the edges. I'll be using the large 10 by 50 millimeter dominoes. These things are they're almost an inch wide, about 3/8 inch thick, and almost a couple inches long. So I'll use 3 of them, keeping 3/8 of an inch between each domino and between the nearest edge, so that there's plenty of strength and the wood won't split. So I've drawn lines across the joint, and I'll use those as a guide for the domino machine when I cut the mortises. There we go. It's time to fit the panels for the top and bottom. So I've taken the, in this case, the frame of the top, and I've assembled it dry with 2 dominoes in each corner. I've checked for square, and now I've taken the panel, and I'm going to make a 1/4 inch deep by 3/8 inch wide groove all the way around the inside of the frame with a corresponding tenon or tongue on the panel. I want the panel to be able to expand and contract. Now this particular panel, the moisture content is right around 7 to 8%, right where I want it for this area inside. So I'm going to give this panel probably maybe a 1/16 inch overall extra clearance to move, whereas one of my other panels is a couple % higher than that in moisture content, so that panel I've cut very tight because I know it's going to shrink over time. Okay, when I try to figure how much wood movement I'm going to get on that inside panel, I do a calculation. I need to know how much red oak moves per change in moisture content. So I've got 1/4 sawn red oak. I've got a wood movement reference guide I got from Lee Valley. It's got a lot of this data on it. And for radial or 1/4 sawn red oak, you get 0.0016 inch of movement per inch of width of the board per % change moisture content. So this board's about 12 inches wide. So if I take that 0.0016, multiply it times the 12 inches, then I can see that I'm going to get a 0.0192 inches of movement for every change in percent moisture content. Oh, let's just say that the moisture content in this wood seasonally might change 2%. That's probably higher than it really would change, but we'll throw in 2%. So I'll just go ahead times 2. That gives me a 0.0384, which looks like it's about a 32nd of an inch. Let's see if it is. Yeah, it's a little over a 32nd of an inch. So what that tells me is this quarter sawn panel, pretty much worst case, is going to grow a 32nd of an inch. So I've given it a 1/16 of an inch of clearance. I'm in great shape. There's no way this panel is going to bind up. And you can do that kind of calculation for every panel and every wood you have. Okay, so the first thing I do is I mark a 1/4 inch in line on each of 2 sides of a corner. I've already done the long side here. Now I'm going to do one of these short sides, which I've just squared up on the radial arm saw. And then I can fit this under the opening. I know I'm not going to get any movement in length, so I can be pretty tight on the length of this, but the width I got to be careful of. So I'm going to go ahead and find my line there, and then I'm going to move on in about a 1/16 or so. Try to stay even on both ends. Okay, so I've got the frame past the line I scribed by about a 1/16 of an inch. So now all I got to do is just take my pencil, go ahead and mark. Now I've marked that outline of the frame, and then all I got to do is cut my material 1/4 inch outside that line, come back and cut a rabbet on top and bottom so I end up with a tongue, and automatically this piece then will be such that it will fit within inside this frame with a 1/16 of an inch to spare. I'm using my 3/8 inch cutter with a bearing set for a 1/4 inch depth to cut a groove around the inside of the frame pieces, being careful to use the top face as the reference. Cut the tongues on the panels that go inside the frames for the top and bottom. I'm going to just score the cut with my saw here set to about 1/16 of an inch, just so when I use the shaper to cut the tongues I won't get any tear out right at the top surface that I want to keep very nice. To cut the tongue on the panels, I'm using my tongue and groove cutter set for the shaper. I've got a 3/8 inch cutter, 3/8 inch cutter, and then I have a spacer in here that's a 3/8 inch. It's also a cutter, but right now it's just acting as spacer. The cutter is actually recessed a 1/4 inch, which is just right for my application. So I've just set the very bottom of this cutter flush with the top, and that's what will be the face side of the panel, so that it will sit very even with the frame. And so I'll just go ahead and put down my guard and my little keeper here, and we'll go to work. I'm doing work with a lot of joinery, I want to finish all those places that you can't get to easily to clean up after you've assembled the pieces. You know, places like the insides of these rails. I like to get the finish on there so I don't have to be trying to sand corners. I don't like sanding corners. So I've got some 1 pound cut blonde shellac here. That's 1 pound of shellac flakes per gallon of denatured alcohol, and a little wiping pad, just some cotton folded up. And I'm just going to go ahead and get those inside surfaces that I can't easily get. I'm doing the same thing to the undersides of the panels because I won't be able to get at those. But the top sides of the panels, I can go ahead and sand those down along with the tops of the frames to get everything nice and even, and then go and finish that after assembly. I just wipe this on, let it dry. It dries fairly quickly, and then I'll sand it down. I'll probably use 320 grit sandpaper, and I'll do a few coats until I think it's got the protection that it should have. The dominoes make the alignment pretty good, but not perfect, so I'm coming back with my low angle smooth plane and just kind of clean up along the edges here to get it as even as I can. Getting the center panel smooth the way I want it, I've been using a cabinet scraper to kind of smooth out some of the marks from the tooling, from the planer. Just a plain old cabinet scraper that's tuned up properly with a good burr, because then I can just adjust it at will, just by the amount of flex I give, the angle that I approach the work, etc. When a side gets dull, I can flip it over, start a new side. And then to finish up the work, I go ahead and use some sandpaper, because the oak does have a tendency to kind of stay rough with the scraper. And so, got a little 220 sandpaper on my Rotex sander. Just go ahead and sand it down some. Here's the part that's a little dicey. I have to put a 45-degree under bevel on the top, and this top is almost 50 inches long, and I thought about all the ways to do it, and I decided the best way is to use the table saw set at a 45-degree angle, but that requires me to use the rip fence on the short end of the board as a guide. So I made a couple of test runs to make sure it would slide well, and I'm using a couple of these foam padded push blocks that grip really well. So I'll be carefully making sure I'm up against the fence the whole way through. There we are. Difficult cut, but done safely. Finally, we get to the part that I really like. Putting on some 1 pound cut blonde shellac. Just watching that wood figure come out. I'll just be putting on several coats of these with some sanding in between. I work up to around P400 or P600 grit, and I'll know I'm done when it feels right. It will have this nice silky smoothness. If you go any farther than that, you're just going to be balling up your finish with the sandpaper, getting nowhere. So once it feels silky, that's where you stop.